today, I know we started working on this last week. This is due by midnight. If you guys leave here and you don't quite have it done, you can hand it in to me on Thursday. Okay? But I want this completed and handed in from you so that I can see how you're doing. Anybody need an extra copy of this? Yeah? Well, I added 2 ed puzzles on to Classroom, and I want you to do those 2 as well. And I found something neat when I was looking for ed puzzles. I found the gal in the one ed puzzle that she talked about ions like Legos. Okay? And so if you pretend this is a Lego, and this is a Lego, and this is a Lego, okay, you have the different number of bumps on top of the Legos, okay, and so she uses these to represent different ions. Like this would be, pretend, a +1 ion. That would be like NH4. What is NH4? Look on your cheat sheets. NH4 is, it's on the bottom on the left-hand side. Ammonium. Yeah, NH4 is ammonium. Now, that 4 right there, that has to stay just like that. NH4 means 1 nitrogen and 4 hydrogen atoms all go together to make up this ammonium ion. So this Lego represents an NH4 ion because what's the charge on an ammonium? It's just a +1, right? Magnesium, on the other hand, Mg, which is a monatomic ion, it's just a metal, it's just Mg, and it has a +2 charge, so I'd use one of these Legos for that. Okay? This +4 over here, Pb, stands for lead. It's a +4 ion. Now the whole point when we're writing formulas is we want to try, here's an iron right here, +3. We want to try to match up the charges so that they balance each other out. So let's say, I'm going to go down the side here too. OH, that has to stay together. That's a hydroxide. It has a -1 charge. So I'm just going to put a 1 bump Lego there. Okay. SO3 is sulfite, and it's SO3. Do not ever, ever, ever change the 3. That's what makes it sulfite. So it's 3 oxygens. PO4, same thing. Do not ever change that 4. So these right here, where you have more than one ion or more than one atom in an ion, these are called polyatomic ions. Poly means many. Okay? These single element ions up here, like magnesium, potassium, lead, where they're just one element, those are monatomic ions. Okay? So when we're writing formulas for these, we want to mix and match these, cross-match these to form an ionic compound. All of the ones across the top are positively charged. These guys are your first names. Whenever we're writing formulas, we always put the cation, the positive charge, first. Okay? And going down the side, these are the last names for our compounds. The anion, the negatively charged particles, come last. Okay? Now, if I were going to write the formula for, let's do an easy one first. sulfur, if I'm combining sulfur and magnesium together, sorry, they don't quite fit. Sulfur and magnesium together, I would just write the symbol for the first name first, which is Mg, and the symbol for the last name, which is this sulfur, which becomes sulfide. You're half done. Now you have to check charges to see if they balance. Sulfide is a -2. Magnesium is a +2. Do those match? So you're good to go. That's it. You're done. You don't have to put 2 and 2 because that would reduce to 1 and 1, right? We want the basic ratio that evens those positive and negative charges out. What if instead I'm hooking it up with this phosphate? I want to write the formula for a combination of magnesium and phosphate. So you write the positive one first, Mg, and then I write the negative ion, which is the PO4. Got to keep that all together. Okay. Now we want to check charges to see if they match. Okay. Here I have this 2-bump Lego representing my magnesium, and I have this 3-bump Lego representing my phosphate, right? Okay. Are those walls, if I was building a wall with those, are those the same size? No. Okay, so they don't balance each other out. How many of each of these do I need to build a wall that's the same length? Well, if I add another magnesium ion like that, does that work? No. I have 4 bumps to 3 bumps. So I'm going to add another, I need some more phosphate, which is this. So I add another phosphate. Now are they the same length? No. So then I add another 2-bump Lego, which is my magnesium. Now are they the same length? Theoretically, yes, they're supposed to be, right? You've got 6 bumps here altogether and 6 bumps here. So it's magnesium. I need, these are my magnesiums. I need 3 of those. And I need 2 phosphates. Now you already have a number down below here. So what you want to do is if I need 2 of this whole thing, I'm going to put parentheses around the PO4 and double it. Because I want to make sure I double everything that's in a phosphate. That's double the phosphorus, double the oxygen. So we use parentheses to keep those groups of atoms together. I kind of liked the Lego trick because it's real quick. It's a different way and a quick and easy way to visualize what's what. So I'm just going to pull these off for a second. And let's try a different one. How about NH4, which is ammonium, and OH? That's been a hard one for students. Okay, NH4 and OH. Which one comes first? The top one here, the positive ion. So I'm going to write NH4. Remember, you just write those groups the way they appear. And then OH comes behind. That's another group, right? It's got oxygen and hydrogen in it. Now, do these balance? Positive and negative one? They balance. So you know what? You're done. You can just leave it like that. This is ammonium hydroxide. How about magnesium hydroxide? Mg. And then we have our hydroxide. This one's a 1-bump. Hydroxide is a 1-bump Lego. Magnesium is a 2-bump Lego. How am I going to make those two match? I have magnesium and hydroxide. Obviously, I'm going to need another 1 bump Lego, which is my hydroxide, to match up with this 2 bump magnesium. So magnesium is, I only need 1 of those, and I need 2 of the hydroxides. This O and H, we want to make sure that we put parentheses around that because it's a group. And we need 2 of those, so we'll use the subscript 2. What would be the problem if I left off the parentheses and I just put a 2? How many magnesiums are in this one? 1. How many oxygens? 2. How many hydrogens? 2. Because this 2 applies to everything in the parentheses. We want it to apply to the whole polyatomic ion. Here, the only thing that's getting doubled is just the H. So this one would be wrong. Okay? Parentheses matter. Whenever you have these polyatomic ions, ammonium, sulfite, phosphate, nitrates, sulfates, whenever you have those groups, if you want more than one of them, you have to use parentheses. If you were gone or you were distanced at any point, this should be online for you, and you can do it on a separate sheet of paper. Also, there are 2 ed puzzles that you need to do. Also, don't forget, you should be working on your project in your free time. Okay? So if you're done with everything else, you can work on your projects. Don't forget, here's your list. Of things that you need to include in your slideshow.